All right, let's see how we did. So page 6768, let's look at it. This was last night's homework, so I think I can squeeze all 6 problems on one. Let's do it. It's going to be a little messy. So let's see, who should we pick on? Garvey, if this was my original graph, and then I'm going to do this, which is in parentheses, will it shift it to the right, to the left, shift it up, shift it down, shift it to the right? Good, it's always opposite. So this is going to take everything and go right 3. So if I go 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So that's what that parabola is going to do. Those are the points. And just to save space, we won't. I guess I'll go ahead and draw it up there. That'll be all right. All right. Next problem. They wanted us to do f at x minus 3. Angela, this one's a little bit different because the minus 3 is not part of the parentheses. So it's not going to shift it to the right or to the left. What do you think it's going to do to this problem? It's going to go up and down. And it's minus 3, so what do you think it's going to do? How many? 3. So every one of our points is going to move down 3 off the red.
So you wouldn't go for the blue. You're always going from the red.
Yeah, so the red is going to be our parent function. Cool? All right, so down. Then the next one says for us, it's got a combination of events. Let's do it purple. So 3, we're going to do f at x plus 2 and plus 3. Casey. So I have something in parentheses, which is going to control the left, right, and I have something that's not, which is going to control the up, down. So which way is it going to shift, left or right? Left, how many left? 2 left, and is it going to go up or down? Going to go up, and how many up or down will it go?
3.
Go up 3. So again, I'm starting from the red, that's our parent function. So I'm going to go left 2, up 3. 1, 2, 3. And then this point here, I went left 2, 1, 2, up 1, and then I went that point. This point would go left 2, up 3. I went too high on this point. That one doesn't exist. Sorry. Ooh, I can do this. All right. So, come on, make it work. So it's going to go left 2, up 3. Excuse me. Left 2, up 3. 1, 2, 3. Left 2, 1, 2, up 3. 1, 2, 3. Left 2, up 3.
Couldn't you just do 1, 3, 5?
Oh, yeah, absolutely. So you move the vertex, and then my voice is going right now. Sorry about this. You're absolutely right because I'm not. I like that exact thought process because you're not taking all the points. I like that. Good idea. Let's see. Problem number 4. Try an orange, see what that does for us. Number 4, 2 times that. And this is the one that's going to change to 1, 3, 5. It's going to change it to what? So am I still going to use the same vertex on the red problem?
Yes.
I am. It's not shifting. It's just stretching. So this works here and here. And then I'm going to go right 1 up 2. Left 1 up 2. And then I'm going to go right 1 up 3. or not 3, 6. Right one up 6. 1, 2, 3, 4, 5, 6. Left one up. What did I do? So you go right one up 2, right one up 6. Excuse me. The thought process you have, Steve?
No, I was looking at the point that was like right next to the board.
Oh, I got you.
Yeah, I thought that was the.
Gotcha. Did I do it right? Right one. Yeah, it's worked out. Yeah, it worked. Oh my goodness, there's getting to be a lot of stuff up here. And I have 5 and 6 still to go. Woo! All right. Number 5. What had I said that the negative x does? So this problem is going to be really hard to see the change. Why is that? Why is our red parabola symmetric about right now? Yeah, it's sitting right on the origin. It goes right around. So this here means that this still stays here. This point actually came to here, but this point comes here. This point comes here. This point comes here, and you're like, wait a minute, that means it's the exact same graph. It is, on this case, it is, because the parabola itself had shifted. If we had changed that, like if the blue was our parent function, though this isn't going to change, this point here is going to come, all of our values are going to switch. So we'll see one later that's going to change that a lot more. Let's do...
Use the calligraphy pen.
Which one?
Calligraphy pen.
Not do calligraphy. This one? Yeah. There we go. All right, 6. Ooh. Yeah. How do I graph number 4? Number 4 just took the red graph and stretched it up. Same vertex, but it's not going to grow at 1, 3, 5. It's going to grow at 2, 6, 10. Oh, I can't get that in my head real fast. And then this one, what is that negative out front going to do? It's going to change it upside down. So I'm going to still have this, but I'm going to grow downward now.
So it's just the same as the parent function, just you're going negative 1, 2.
Uh-huh. Exactly. And that's kind of a unique one because x squared is the most plain version of a parabola you can get. So not all of them are going to shift around. All right, can I move on?
Yes.
All right. Everyone with me?
Yeah.
That's pretty colorful. I haven't gotten that many colors for you ever. So, all right, number 7. They don't really tell us what the function itself is. We probably could figure it out by looking at it. But what we're going to do is let's just run through with A. We're going to do function at x plus 2. Okay. Andrew, what's that plus 2 going to do to us? Yeah, the whole graph's going to move up 2. So this point's going to move up 2. This point's going to move up 2. This point's going to move up 2. What'd I do? Oh, but my original, I didn't really see 5 points on my original. When I was looking at the graph, I saw that I had 1, negative 2. And then I saw that I had 3, 2, and negative 1, 2. So I only had 3 points that I was able to establish originally. So we're pretty much fine. What's that? Oh, I see what you're doing. So you're going. Well, I couldn't see really that it went right one. Oh, maybe it does go right one up one. Maybe so this point here There was a point here and a point here that I established. So those both go up 2 as well. So that's right there on the line. I didn't see that originally. I'm sorry. I was just trying to go quickly. All right, here we go. B. Function at negative x. Function at negative x. So this one, on the last one, we didn't see it change it much. It just took the whole graph and kind of flip-flopped it. But this one is actually going to change. This is going to change the sign on all x values. So if it's positive, it's going to be negative. So this point here, 1, -2, is now going to be -1, -2. It didn't shift the graph, it just changed it. And then this point, rather than being 1, 2, 3, or let's go with this original point here. I'm looking right here. So I got 1, 2, 3, 1, 2. So it's 3, 2. So now it's going to be -3, 2. And then this point here was -1, 3. Now it's going to become +1, 3, which is right there. And again, I'm just using the 3 points. I think we could establish enough of those 3 points to see what the graph had done. It appears that the graph did shift over. So sometimes some of these will mimic something else. Steve, quit throwing stuff at Angelo. He doesn't deserve that. That's the last thing I need is Angelo to start crying and curl up in the fetal position in the back of the room. Letter C. All right. Angelo.
Yeah.
I'm picking on Steve now. Steve. What's this one going to do? Purple. Purplish.
It's going to go
Left 3 and up 4. So for my original function, I'm going to go left 3. 1, 2, 3, up 4. 1, 3, 4. There's my vertex. Take this point. 1, 2, 3, up 4. 1, 2, 3, 4. Take this point. 1, 2, 3, up 4. Sweet. Looking okay? Feeling all right?
Oh, that's nice.
Yeah. Okay, when it is in parentheses, you go the opposite direction of what you think you would do. So because it was a +3, I'm going to go to the negative. And if it was a -3, if it was x -3, I would go right. Okay, so it's always opposite inside, same outside. Number 8. You guys okay still? Some of you are chatting a little too much. Hey, how you doing there, Cupcake? Ain't very little. Yeah, buddy. Gage, the good news is, looks like you're still supposed to be in my class.
Thank you very little. Like you made a special trip here.
You ever see the movie Caddyshack? That's what Chevy Chase always says. Think you're a little. Thank you very much. All right. Here we go. Letter A. Gabe, what do you think it's going to do?
Sorry.
Yeah, you're okay.
It's gonna go
Down 3. Shh. So this one, our parent function is already upside down, so all of our points are going to go down 3. So 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Yeah, baby. All right, no applause, just throw money. Letter B. Letter B is negative. Someone is throwing money this time. Yeah, baby. What does that negative do out front? Which values does it change? Changes the y values. Okay? So we're looking at it red. We're changing our y values. We're making them opposite sign. That's also going to flip it over. Huh. You gotta do this right?
Wait, can I make a suggestion?
Yeah.
Wouldn't the values go to the opposite side? Or wouldn't they be like opposite?
Hang on, let me think. Let me think. Because I was just thinking.
We did that. It was number 6.
We did number 6?
Yeah.
What did we do?
The last page, it was all values to opposite side. It was negative and.
So this would be like saying this.
Hey, what the? Buddy. You're listening to me.
So that's basically what it's doing, that. So if this was the parent, made a functional notation, made it negative on one side, that makes it, so it becomes a negative x squared. So what is that going to do? What did I say is the rule on that, Reese?
All values to opposite side.
Didn't it only do that because
That was on that one.
No, it was the last one. See, look,
6.
number 6 right there. See?
We flipped it over.
You know what I'm saying, dog?
Yeah, dog.
You know what I'm saying?
Yeah.
Thanks. They get flipped.
It is flipped. Yeah.
Upside down.
Here we go. So let's go do this one I'm supposed to be on.
Yes.
Red one's the parent. All right, here we go.
So it just goes up.
Here.
Yeah, I'm right.
Love you, Reese.
You're welcome.
Wait, Mr. Strobe, isn't it supposed to go negative over 1 down 1?
That's where it got weird. What is our parent function doing right now?
Down.
It's opening down. So that means the other one's got to open up. That's where I started mixing it up in my head because I wanted it to still open up.
No, but why would it open up if it's negative 1?
Because the parent function is already a negative x squared somehow. So if I do the negative negative, then it makes it positive. Oh, yeah.
You have like the same
Shh.
go down to y being negative, could it like flip sideways?
We're not. Ew. In order to get it to flip sideways, you have to have x equals y squared, and then that will open it sideways. But we're not going to deal with those in this class yet. The closest we'll get is something that'll look like y equals the square root of x, which if you squared both sides, then it becomes the same idea. But it's only one side of it. It doesn't do both sides because the vertical line test doesn't pass on a function. Yeah, right. Okay, this, all this really does is just flips it over. Flips it over. So just flip the whole parabola upside down of what it had been. I think we did a disservice having the one that was right there on the axis originally. I think that this one, or it was like this, doing this. That made my mind weird because I was like looking at it upside down going, wait a minute, it's not working in my head. Because I want the parent function always to be up, opening up, and this one it opened down. So it made my mind go goofy. Guys and girls, there's a little too much chatting going on. Let's see. Purplish. Letter C. F at x minus 3 minus 1. So, right, how many? Bless you.
3.
3 down, how many? Down 1. Right, 3 down 1. So I'm going off the red function still, right? I gotta make it right in my head. Okay, so I'm gonna go right 3 and down 1. And right 3 and down 1. And right 3, down 1. And I'll do that first, right? Okay. Right 3, down 1.
The one. Oh, you just messed up the point. The top point. Oh, okay. We're not supposed to do
Feel
that.
better?
I just didn't know what it was.
I held my pen there too long.
Oh.
It wouldn't count. All right. Shh. So, can we get away from the parabolas for a little bit?
Yes.
Anybody know what that's called?
No.
It's an exponential function.
Whoa.
So it's
Big
like
words.
saying some number raised to the x power. Like 3 raised to the x. Rather than saying like x squared, it's like saying 2 raised to the x or something like that. So all of these rules still apply. Preston, what's this one going to do? Yeah, so I have points that I identify, so each of those points moves up 2. 1, 2, 1, 2, 1, 2. Okay? Now, here's the weird thing. Where does it look like this line is coming to? Yeah, it looks like it's coming to 0. So this line here, this here, is actually going to move up to here. So it's going to do this. Mainly, I'm looking for, did you shift all these points correctly? That's the biggest part. But what really is taking place, too, is this right here is called a horizontal asymptote, and it's going to move up, too, because of this. But we're not there yet. So if you move the points up, I love you. I'm not too worried about the asymptote. B. B does what? Help me out. Reverse which direction, though? Is the red graph going to flip downward, or is the red graph going to flip this way, to the right?
It's going to flip to the right.
Yeah, that's what it's going to do.
Because I would suspect that if the negative were on the F, then it would go down.
So, yes, you're right. So that negative is going to change. So this one is still going to be the same point. Okay? Why is that? Because my y component is 0. But the y component here is going to flip to over here. The y component here is going to flip to over here. The y component here is going to flip to over here. Woo! That's what that one looks like. Ay, ay, ay. Shh. If your neighbor's talking, tell them to hush. Please.
Ben, please.
Ben's out of control, playing with matches again.
They used to play with the saber piercings.
Shift. Which way?
Right 2, up 1.
Right 2. Up. Right 2. Up 1. All right. Shh. So, right 2. 1, 2. Up 1. Right 2. Up 1. Right 2. Up 1. Right 2. Up 1.
So
Oh, yeah.
I see.
I don't know where my voice is going these days. I'm sorry. Starting to go through puberty again. Doing it, almost done. All right. The F is the red, the G is the green. Did I do okay? So, if I went from the F to the G, what looks like it took place? What kind of shift? Minus 3?
Yes.
1, 2, 3. So f of x minus 3, because it shifted f. Is that all right?
Yeah.
That's all you would have to do on that. The hard thing on your paper is it stays black and white. I was able to get you a little bit of color. And then the last one, the F is the green one, and the G is the red one. So going from F to G, what looks like it took place? Shifted right how many? 2. So x minus 2, and it went what? Up 4. So it shifted right 2, so it's negative inside, and shifted up 4, so it stays positive. Huh? They'll be coming. I got to figure out how to get one on to Schoology, but I will. Reminder, Schoology, there's a 30-point one on there. It is due Friday next week. Huh? Yes, you will have whole class, yes. Yeah. Yeah, it's up now. I just put it up, I think last night it was. Cool. And being I think it's 9 problems. So what that means is,
Is it like a 9-problem slide thing?
yeah, 9 slides.
9 slides. Don't say 9 problems, because then you're just going to give off like the wrong thing.
There are 9 individual pages to
There
it.
you go.
Some of the pages have 1 problem, some have more than 1 problem.
Yeah.
Does that make sense?
That makes
All right.
complete sense.
I did make it so it's resumable, so if you did a little bit, and then you went back to it, did a little bit, went back to it. I did that for Reese.
Mr. Sturm,
Yeah.
what time are you gonna be in your office today? Like 12ish?
Yes, I'll be there for you.
I'm gonna.
Dude, look forward to it. Yeah.
It's probably good.
All right. We got 20 minutes to get over, do this. Here we go.
Good basketball.
What?
Starting in 5, 4, 3, 2, 1. Blasting off.
Sorry.
All right. That was your cue to hush. All right, so 1, 2, and 3 go along with this graph, so we'll do all the shifting here. What's this one doing? Yep, up 3. Okay, so I can take all these points, go 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So our new graph looks like that. That's easy. I think these are easy to see. Okay? Now, 2. What does this do? Changes all the x values, makes them opposite to what they were. What point is this right here? Negative 3, 1. So that means I have positive 3, negative 1. This point is negative 2, 1. So it's going to become negative 2, 1. Okay? This one.
Oh.
0, negative 1, so it's what? What do you think? So far I have this. What did it do? So I said that this was -2, but this one didn't change. So is this going to change at all? No, it still stays the same point. Okay. Where am I at now? School, dude. Oh, that's going to become -2, 0. And this one is going to become -3, 2. There's that one. Woo! Retreat. So this changes all x values. Doesn't change the y, just changes the x's. What about this one? Shifts right 2 and up or down? Down 3. So right 2, down 3. All right, so taking this one. We go right 2, 1, 2, down 3. Right 2, 1, 2, down 3.
You say right. You're saying right two down.
I went here, I went right 2, down 3. Well, this one's right 2, down 3.
Yeah.
Okay, sorry, I could be making an error. I just want to make sure. Right 2 and down 3. This one, right 2, down 3. And then right 2, down 3. So, wait, right 2, and 1, 2, 3. I give this one. This one should be. There we go. What is that? Right 2, down 3. I feel like I'm off.
You are.
Why am I off?
It's supposed to go off. You did the purple.
Oh, dude. That one. So I do from the red. I'm sorry.
Yeah.
Right 2, down 3. Is that right now?
Yeah.
Oh, thank you guys. You guys are like the government with me. You're bailing me out. Appreciate it. Huh. That wasn't too bad. Try the next 3. Go with this one. I'll put them up right here. See how you do. You guys working? Oh no. What do you think? What do you think? What do you think? What do you think? All right. Now, this is what we're going to do for the rest of you. Let's to rumble. Steve, that one's for you. Talk me through this one. What did I do? What? Okay, so all of the y values do what? Okay, so y values are opposite. Okay, so if they're positive, they go to negative. If they're negative, they go to positive. If it's zero, say zero. All right, so where am I going to go? Yeah, there you go. Shh. What's this one going to do? Uh-huh. That one? Yeah, baby. So, yeah, negative 1. Still negative 1. What does that one do? If it's negative, it has to go positive. Positive 1. That's here. Let me remove. Where were they?
The numbers?
There we go. So we got and then kind of a curvy. That. Good job, Steve. All right. Who should I pick on next? Hey, Steve, your choice. Mac? All right.
Yeah, that's it.
Mac, what should I do?
The parent function, that you go negative, or over. Isn't that the equation where you just flip it over?
Yeah. Doesn't it look like we already flipped it over?
Yeah, but it's just the same thing.
What do you guys think?
No.
No? What's different?
It's
Are the x values negative?
no.
Yeah, the x values are negative, so this one's flipping which way? It's not flipping. Oh, you know what we did? Did we do that? You know what I did? I can't blame Steve for this. So, this one is actually going to be the purple. And this one, this is where this one would have changed. Uh-oh, so I got to make it right. All right, so we got to redo this one in blue. Ready? There we go. We have it right now.
How do you get that?
So the first one, the top one, all the x values would have changed direction. So it's positive, negative. Then the one you guys signed you flipped over, we did it as purple.
So which way would they change to?
The x's change signs. So if it was like 3, 2, it'd become negative 3, 2. Okay? Alright. I feel okay about this. What about yous?
I'm almost done.
Almost done? Sweet. So, guys and girls, ladies and gentlemen, your assignment is going to be page 71/72, 1 through 6.
Wait, is this smaller? 2?
So if you need to take a picture of it, I have it up in the basket.
What worksheet number is it? 5.
12. Yeah. So worksheet 12, it's in the back.